there, let's talk about how we predict the products of a double replacement reaction. The process we're going to follow is we are going to write our chemical equation, and on the product side, we're going to swap the anion cation partners. That's what makes it a double replacement reaction. And then, this is really, really important, we're going to change the subscripts to balance the charges on the ions. When they switch partners, the subscripts often change. And so we're going to stop and check and make sure that we have an equal number of positive and negative charges before we move on. And then lastly, we're going to figure out which of the products is aqueous and which one is a solid, a liquid like water, or a gas. When it comes to deciding which of the products is going to be aqueous, tip: compounds that contain nitrate, acetate as your anions, or that have lithium, sodium, potassium, or other group 1 cations, those are going to be aqueous. And the other product, if you know what product form is, the other one is going to be the precipitate. If you see water, obviously that's going to be a pure liquid. But there certainly are more solubility rules. That's enough for us. So nitrate, acetate, and then group 1 cations. Those are going to be aqueous. The other thing will be your precipitate. Let's take a look at 3 examples so you see how this process works. First, we're going to take silver nitrate and react it with sodium chloride. As you look at this, think about what your charges are. Nitrate's -1, so silver has to be +1. Sodium you know is +1. Chloride is -1. We are going to swap the cations so that they trade partners. And so our result is going to be sodium with the nitrate and then silver with the chloride. Pause and check your charges. This one's friendly. Everything is plus or -1, so those charges balance out. Almost done. The last thing we have to do, one of these is going to be a precipitate and one of these is going to be an aqueous solution. So looking at our guidelines here, compounds that have nitrates and compounds that have sodium in them, those are going to be aqueous, which means that the other compound must be the precipitate that forms. 2 more. Lead nitrate with sodium chromate. Okay, so for this one, again, think about what you have. Each nitrate is -1. That makes this lead a +2 charge. Sodium is +1. There's 2 of those. That means the chromate has to be -2. So as you look at this, we're going to switch the positive charged pieces here. We're going to switch our cations. And so we're going to end up with lead chromate and sodium nitrate. Notice I haven't included any subscripts yet. We're going to check that right now. The charges will always stay the same on the left side and the right side of a double replacement reaction. And so as I look at this, ooh, it's perfect. Everything is all charged. Charges are all balanced, so I don't need to add any additional subscripts. I do need to balance the equation though. So I'll put a coefficient of 2 in front of the sodium nitrate so that the equation is balanced. All that remains is deciding which one of these will be aqueous and which one will form my solid. Things that have sodium, things that have nitrate, those are going to be aqueous in them. And so that means that the sodium nitrate will be aqueous and the lead chromate must be the precipitate that forms. 1 more. Here I have cobalt chloride reacting with sodium sulfide. Again, start by figuring out what your charges are, and then swap the cations to make your products. So you're going to have cobalt with the sulfur and then sodium with the chlorine. Double check that the charges are still balanced. In this case, everything is glorious, but notice that the subscripts have changed. And then lastly, figure out which one is going to be aqueous, which one's going to be your precipitate. So things with sodium will be aqueous. That makes the sodium chloride aqueous, which means the cobalt sulfide must be the solid, the precipitate that forms. That is your process. Do not skip the checking the charges step. Everything will go bad if you do. So make sure you do that as you're working your problem.